So last class, you may remember, you counted up the faces of the cube, and you got 6. You counted up the vertices, you got 8. And there you counted the edges, and you got 12. And last thing to recap to last, you were asked to check out if this was true, that faces plus vertices is always more than edges. So you said 4 plus 4 is 8. Is that more than 6? 6 plus 8 is 14. Is that more than 12? And 12 and 20 is 32. Is that more than 30? Okay. And then every group came up with it, whether it was a sentence or whether it was an equation, although we were trying to do an equation. What did we notice about the sum of faces and vertices compared to the number of edges?
There are always 2 less.
There's always 2 less edges. So we came up with 2 ways to write that. The first way we wrote it, I'm going to do it in a different color so it pops, was something like F plus V minus 2 equals E, or F plus V equals E plus 2. Either way, you guys said there's always 2 more in the sum than there are the edges. And that's what these 2 equations say. So what we're focused on today is writing equations that represent things. Not even solving anything, writing equations that represent situations. So next, it's on the back of the notes you started. You're going to do the same thing here with blueberries and summer wages. So the first ones are going to be about blueberry prices. The next one's going to be about summer wages. And you're going to be asked to compare and contrast those. Now, looking at the directions, are you going to solve anything?
No.
Write an equation.
Yes.
Okay, so not solve anything. We're writing an equation only. Let's get after it. Looking here at your boards, looks like everybody was pretty much on the same page. For these blueberries, we're going to be $4.99 a pound. For B pounds, totals $14.95. Do you guys see how I could just like read the sentence and my equation is that sentence kind of, right? It's like we're translating. So blueberries are $4.99 a pound, P pounds to get C dollars. So this one we don't have a total. $4.99 a pound for P pounds totals C dollars. And the third one, they cost D dollars a pound per Q pounds totaling T dollars. So again, I just want to reiterate, as I'm writing this, it is the sentence, right? It is the sentence. So looking for Noah for D, here in N dollars, may earn $275, which is 45 more than Noah. So this is how I read that. 275 is 45 more than Noah. Did anybody write something like N equals 275 minus 45?
That's what we did.
These are the same, okay? Noah earned V dollars over the summer, may earn M dollars, which is 45 more than Noah. So I see M dollars is 45 more than Noah. Did anybody do V equals M minus 45?
We did, but then we took it.
That's fine. That works too. And then Noah earned W dollars over the summer, May earned X dollars. So X dollars is Y more than Noah. So W plus Y. Let's look around. See. Did anybody say W equals X minus Y? I take that too.
Yeah.
That works too. So now we're going to look at similarities and differences. So looking at this cluster of 3 and this cluster of 3, what is the same? What's similar between all the 2 situations? What's similar? Yeah, right.
They both are about money.
About money, okay. What else is the same? Yeah, Georgia.
Same people. Dealing with the same people.
Diego. Oh, no, we got
Oh, no, we're not.
Diego. So that's differences. Let's put that over here. Different people. Okay, what else is the same between them?
About money.
You got that one about money. What else? Variable. Oh, I see that's a good one back there. Variables and numbers. Did we notice what happened to the progression?
Slowly turn into
1 variable, 2 variables, 3 variables, 1 variable, 2 variables, 3 variables. So I don't know how to write that. 1 to 3 variables. And they all have 3 pieces to them, right? That's why we can have 3 variables. What's different? So we got different people. What else is different, Ben? What else is different between our situations?
The bottom half has to do with top half. Bottom half does, or never mind, that's something to say.
Okay. What operation's happening done? Oh, different variables. I'll take that. Different variables. Okay. What about operations between the top one and the bottom one? Lulu?
I was just gonna say that one is like losing money, one's like making money.
Oh, one's spending versus earning?
Yeah.
I like that. Spending versus earning. Okay. What about computation, right?
One is about times, one is about.
Yeah. We got multiplication up top and add, subtract on the bottom. Those would be a lot of the differences. But they're all ways to represent situations through equations. Did you know that when you buy a car at like a car dealership, that there's like a sticker price? Have you ever heard of that, sticker price? Okay, and the sticker price is not how much you end up paying. You pay more than that, okay? And the two main parts that you pay is sales tax. In Michigan, it is 6%. And you pay some miscellaneous fees, usually associated paperwork, registration, stuff like that. Because a lot of times at a dealership, you'll leave with a license plate, and that costs money and stuff too. So this dealership in Ann Arbor, it's in Michigan. So again, 6% sales tax and $120 in fees get added on to the sticker price. So it's your job to answer A, B, C, and D of what the totals, or just make sure you read it. Okay, I want you to make sure you read C carefully, actually. You're going to write the equations that represent those situations. Do we need to solve anything? No, we don't need to solve anything. So, just equations that match. So for the first one, here's what I've got. The original price is $9,500. So $9,500. I need 6% tax. So I'm going to multiply that by 1.06. Here's why. 9,500 times 1 equals what?
7.
No, 9,500. Anything times 1 is itself. Okay? Then the 6% is extra. That's the 6% tax. Then I need to tack on my 120 to equal my total. I want to give you 30 seconds to go through your next ones to change anything in case you want to.
I think this is.
Once we fix these up, the second one should be $14,699 for the car, 6% tax, $120 in fees for a total. Okay. Now this next one, a lot of people said stuff in their equations like the car is $22,480, but that's the total. Because it says the total. Okay. So to get the total, we have the price of the car times 6% tax plus $120 fee. So make sure you can make sense of this right here. The price of the car, 1.06 for the tax, 120 for the fee to get to the total here. So it changed what information we had. Lastly, number 2. If we wrote this for any kind of percent in any kind of price and any kind of tax, it might look like this. And this is a little tough to write down, I'd say. We've got P for the price. For the tax, I'm going to do 1 plus R over 100. So if it were 8%, it'd be 8 over 100. That's what percent literally means, per 100. So this 1 plus R over 100, that would give us our 1.0 whatever, or if it's 12% tax, 1.12 and so on. Then I need to add on my $120. Oh no, sorry, miscellaneous is M to get a total. So let me just take us through this again. This is the equation that works for everything, and this equation is the situation. The price of a car, P, times 100% plus the percent of the tax. So again, ours is 6%, 1.06, plus the miscellaneous fee to get a total. And this is really what happens at a car dealership. If you go in and say, I want this car and it's $20,000, they're going to add tax and fees to it, and it's not going to be $20,000 when you leave. Okay? That's what happens. And if you buy it private party, you actually have to go to the Secretary of State and say, I paid this much for it, and then pay them the sales tax for the purchase as well, even if you just bought a car from somebody else. In your assigned seats, you're going to work on the lesson summary. Erase your stations, please.